start talking about a relation in this class. So remember that we start talking about sets. We say that a set is a collection of objects. Very good. We denoted sets by A, B, C, S, T capital letters. And remember that we perform different operations on sets, like the union, then we had intersection, then we had set difference. We talked about the complement. But there are other ways that we can form a new set. For example, new set. In algebra, you learn that, hey, we can have a two-dimensional plane. In algebra, you had a line representing x-axis or r, real line from negative infinity to positive infinity. We added infinity. Then you move to pre-calculus, calc 1. And then we said that, hey, we can move this one-dimensional space into a two-dimensional space, right? This is just one dimension. They can create a two-dimensional space, x-axis, which is just r, and the y-axis, perpendicular to that, is r, representing two-dimensional plane. And then we expand the idea and we introduce three-dimensional space, 3D. We say that, hey, we have our x-axis, we have our y-axis in this space. So one by one, we try to generalize the idea, expand the idea, and create something new in math. But how do we define these? These are the definitions of Cartesian product between sets. For example, if you have a set like A and another set like B, you can form the Cartesian product between them. A Cartesian product. B is the set of all ordered pairs, all points like x and y, such that x belongs to the first set and y belongs to the second set. Of course, you can expand the idea and have the Cartesian product between three sets, and you get triples, x, y, z, such that x belongs to the first set, y belongs to the second set, and z belongs to the third set, c, like points in the space. So these are the definitions of Cartesian products. When we're talking about Cartesian product, we are introducing relations. So we take two sets and we define a new set that is formed by using the Cartesian product. So recall that at the beginning, we said that a relation like R or T or S, R, T, S, so on, is a subset of Cartesian product between two sets. Cartesian product between two sets like A, Cartesian product B. That's how we define a relation. That's the definition of a relation. So suppose relation R is a subset of Cartesian product between A and B. Guys, do not confuse this R with this R. This represents the line, real line. This is just capital letter R, a relation, subset of Cartesian product between two sets. So R is a relation which is a subset of Cartesian product between A and B. We say that a point ordered pair belongs to relation R, and we can represent it by X is in relation with Y. So you read it this way. X is in relation R with Y, or the point or the pair X and Y belongs to this subset. R is a subset of Cartesian product A and B. So let's just add, there's a possibility they're equal to each other as well. Okay, let's go over a couple of examples. We're going to define some relations, and then we're going to analyze how to deal with those relations. So I'm going to write this definition up here. Relation like R, S, T, anything that you like. T is a subset of Cartesian product between A and B. Then you say that a point ordered pair belongs to that relation if and only if X is in relation with Y. And then you're going to check each one of these. For example, I'm going to define a relation this way. We define relation L as, so I'm going to just define this relation. I'm going to say that, hey, X is in relation with Y through L if and only if X is less than Y. Remember that the domain that you're going to work with is going to be real numbers. This bolded R represent real numbers, as you learned in algebra. Okay, very good. Now we're going to answer the following question. The very first question says, hey, is 57 in relation with 53? Okay. B, is negative 17 in relation with negative 14? Okay. C, how to visualize this relation L. Okay, it shouldn't be that hard. So my X is 57, my Y is 53. Can you say that 57 is less than 53? Guys, the order is important. This guy comes first, this guy comes second. We cannot change the order right now. So, of course not. What about negative 17? Negative 17 is less than negative 14? Yes. So how do we visualize this relation. It says, hey, X is in relation with Y. You have a point or their pair belongs to relation L if and only if X is less than Y. Just going back to algebra, pure algebra, and graph it. Graph this inequality in 2D, in 2 dimension. Well, okay. So you have your x-axis, you have your y-axis, x equals to y. Well, here you have a dotted line because there is no equality. And you're going to shade numbers on the left-hand side. Right-hand side is not acceptable. All x values that are less than y values. You can use a checkpoint like 1 and 1. 1 and 1 is not going to be on this line. 1 and 0, 1 is not less than 0. So 1 and 0 is not on this shaded part. You're going to shade this part of the plane. This is your relation L. L is a collection of points, or in this case, the solution for this inequality. Points or the solution for this inequality.